This video, we are solving a problem of simple harmonic motion. Let us see what is the problem. If V1 and V2 are the velocities of the particle in simple harmonic motion at displacements Y1 and Y2 measured from the mean position, what is its time period is? That's the problem, right? So first we shall know what is the equation for the velocity of a particle in simple harmonic motion. We have derived this equation. V can be written as omega into root of a square minus y square, where y is displacement, a is amplitude, omega is angular velocity, v is the velocity of the particle at that particular displacement y. Now, at displacement y1, velocity is v1. If you write that, velocity is v1, amplitude doesn't changes, it is same for a displacement y1. For a displacement y2, velocity is v2. So I can write one more equation. V2 can be written like omega into root of a square minus y square. I can eliminate omega, of course, by dividing these two equations, but we need omega because we want to calculate time period. So omega shall not be eliminated in this equation because omega can be expressed in terms of time period. As we said earlier, omega is angular angular velocity is rate of change of angular displacement d theta by dt. When a body completes one rotation, angle covered is 2 theta, time taken is time period t. So once if you have omega in your equation, you can use it as 2 pi by t and get the time period that we want in the problem. That's why omega shall not be eliminated. So what can be eliminated? Acceleration can be eliminated because that is not necessary. It is, we want answer in terms of y1 and y2, so acceleration can be eliminated. So what I will do is from these equation 1 and 2, I will find out what is acceleration is simply by squaring that equation. 1 square gives 1 square equal to omega square of a square minus y1 square. So um, here v1 square equal to omega square a square minus omega square y1 square. So a square can be written as v1 square. Get this term omega square a square. Let's find by taking this term to the other side plus omega square y1 square. So a square is equal to v1 square plus omega square y1 square by omega square. That is from equation number 1. I can do the same from equation number 2. What I can write from equation number 2? That is this equation. I will just do the same. I will square the equation. Theta square equal to omega square of a square minus y2 square. So v2 square equal to omega square a square minus omega square y2 square. Take this term to the other side. So v2 square plus omega square y2 square equal to omega square a square. That implies a square can be written as v2 square plus omega square y2 square by omega square. If you notice, this is a square, this is also a square. Both are same. Amplitude of that simple harmonic motion square. So we can say as x is equal to y, both LHS are a square, we can equate RHS of x and y. What happens when you equate their RHS? Let's do that. Yes. v1 square plus omega square y1 square v omega square, this one, equal to this one I have to write. v2 square plus omega square y2 square by omega square. Now I can cancel this omega square. So get that v2 square to this side this term to that side. Omega square y2 square minus omega square y1 square. I can take a omega square common in both these terms. Y2 square minus y1 square will remain equal to v1 square minus v2 square. Yes, omega square will become v1 square minus v2 square by y2 square minus y1 square. That's omega square. Take the square root on both the sides. Omega will become v1 square minus v2 square by y2 square minus y1 square. And I told you, once you got omega, omega can be equated as 2 pi by t as v1 square minus v2 square by y2 square minus y1 square. This implies you want time period, right? So take the time period to that side and another equation to this side. Time period becomes 2 pi into root of y2 square minus y1 square by v1 square minus v2 square. That's how we can find the time period of the body of that particle in simple harmonic motion. So all this expression depends on this simple equation. Velocity of a particle in simple harmonic motion is omega into root of a square minus y square. You need to know that. If you don't know that, I have derived that equation. Please once go through the previous video so that you can understand how to derive that equation. Right? Thank you for watching.